has to come to an end sometime. Here we are at Physics Virtual Lab, Delhi Public School, Bangalore East, Grade 12, with a concluding experiment on semiconductor diodes. Experiment 8. Aim to draw the IV characteristic curve of a PN junction in forward bias and reverse bias. Apparatus: PN junction, germanium diode OA79, voltmeter of range 0 to 1.5 volts, voltmeter of range 0 to 30 volts, ammeter of range 0 to 15 milliampere, and ammeter of range 0 to 100 microampere source for biasing. Theory for forward bias. The forward bias condition, the negative of the battery is connected to the N-type, the negative of the battery connected to the N-type and of the material, and the positive of the battery connected to the P-type of the material. Electrons from the N region cross the junction and enter the P region due to the attractive force that is generated in the P region. The electrons are attracted and move towards the positive terminal. The holes are attracted to the negative terminal of the battery. By the movement of the electrons and holes, current flows. So this is the positive. The electrons will be moving like this and it will be attracted towards the P junction, so they cross over and to the P junction and they move back to complete the circuit. In this condition, the width of the depletion region decreases due to the reduction in the number of positive and negative ions in the depletion layer. The depletion layer decreases. By the supplying voltage, the electrons get enough energy to overcome the potential barrier of the depletion layer and cross the junction, and the same happens with the holes as well. This is known as knee voltage or voltage drop. The voltage drop across the diode occurs due to the internal resistance. Current is due to the majority charge carriers in forward bias. The reverse bias theory, the negative of the battery is connected to the P-type and the positive is connected to the N-type. The depletion layer increases over here and the current is due to the minority charge carriers. When the reverse voltage is increased beyond the limit, then the reverse current increases drastically, and this is known as breakdown voltage. And before breakdown voltage, the current is due to minority charge carriers, so the current is very less, a few microamperes in the circuit. This is the entire apparatus. Now this apparatus is already wired and it is in two parts. So till here we use for forward bias, and when we are using for forward bias, the reverse bias knob should be at the minimum, and this is for reverse bias. And when we are using the reverse bias circuit, the forward bias should be minimized. Minimum voltage or zero voltage biasing voltage has to be applied. So this is the diode. We are studying the characteristics of this diode in forward bias as well as in reverse bias. And for forward bias, you see that the voltmeter and ammeter will be of lesser range. Voltmeter is of lesser range and ammeter is of more range because more current is because of the majority charge carriers. And in reverse bias, you have a higher voltmeter range 0 to 30 volts and low current meter because current is due to minority charge carriers. So we will see the circuit now in detail for forward bias. This is the circuit diagram for forward bias, where we see that the positive of the battery is connected to P junction and negative to the N junction. So we follow this circuit and we try to understand this wiring. The positive, now this is the positive of the battery. The battery is connected across these two terminals, positive and negative. Red is for positive and black is for negative. So from positive it goes to the positive of the voltmeter. So from positive to positive of the voltmeter, which gives you the voltage for forward bias. VF stands for voltage of forward bias, and the negative goes to the negative of the voltmeter, the negative to the negative of the voltmeter, and from there the positive of the voltmeter to the ammeter, positive to the positive of the ammeter, and the negative to the positive of the or the P region of the diode. So from the negative you have the P region of the diode. This is the knob for the P region of the diode, and from the N back to the negative terminal here. So this is how you have the wiring for the forward bias of the circuit. Now here is the circuit for the reverse bias, and this is the apparatus for the reverse bias. The positive of the battery should be connected to the N junction of the diode, and the negative to the P junction. That's the main connection, and then you need to put a voltmeter across the junction to measure the potential difference, and ammeter in series. So we follow this circuit in this on this box as well. You have the positive, so we start with the positive connected to the voltmeter, which measures the reverse voltage across the PN junction. So the positive of this battery to positive of voltmeter, negative to negative. So positive to positive, negative to negative, and then from there the positive of the voltmeter is connected. You can see this wiring, so it is connected to the positive of the ammeter. The negative of the ammeter goes to the N junction. This is the only difference in the circuit, the negative going to the N junction, otherwise this would go to the P junction in the forward bias circuit. So it goes to the N junction, and this is your N region of the PN junction, and the P region is connected back to the negative of the battery. So the P region is connected to the negative of the battery, biasing voltage or biasing battery. Okay, we will be concentrating only on the forward bias here. So this is the biasing potential that we are going to be using, and when I switch it on, you see that you have readings on all the 4 meters, but I am not interested in reverse bias, so I'll use this knob and make the battery voltage very low. Okay. And here we will start recording the readings, and we see how the current will vary with the biasing voltage. So we will be concentrating on only these 2 meters, the voltmeter and the milliammeter. And in forward bias there is more current, as the current is due to majority charge carriers. So when you see this voltmeter, the range of the voltmeter is from 0 to 1.5 volts, and between 0 and 0.25, there are 10 divisions. So the least count, please post the least count of this voltmeter used for forward biasing in the chat box. Similarly, you see the milliammeter here. The range of the milliammeter is 0 to 15. 0 to 15 milliamperes, and from 0 to 2.5 milliamperes you are having 10 divisions here. You can see this part from 0 to 2.5 milliamperes you are having 10 divisions. So what is the least count of this ammeter? You need to post it in the chat box. Okay, so then we continue further with actual taking of the readings. What we do is we take divisions in terms of 5 divisions, in steps of 5 divisions on the voltmeter, and we see what is the corresponding ammeter readings. We see the corresponding ammeter readings. So we start with the first reading. I am going to vary this voltmeter till I get 5 divisions on the voltmeter, and you see what the current meter reading. So note down the current meter reading. How many divisions are there on the current meter? So post your readings in the chat box for the voltmeter and the ammeter divisions. Okay, so next I am going to adjust it to 10 divisions. 10 divisions on the voltmeter. So the voltmeter reading will be 10 divisions into least count. 10 divisions into least count, or directly from the scale you can take the reading, and also the milliammeter, you can take the readings from the milliammeter. From the milliammeter you can take the readings. You can just take down the number of divisions. The first division will be 0, then it is 1, 2, 3. So you can see what is the division that the pointer is reading, and post it in the chat box. Next is 15 divisions on the voltmeter, and check your milliammeter readings, divisions. What is the pointer? Okay, stable at. So now 15, now this is 20 divisions, and note the number of divisions on the milliammeter and post your readings. Note your readings, note down the readings on milliammeter, number of divisions on milliammeter. Okay, then it is 25 divisions on the voltmeter. 25 divisions on the voltmeter, and check the number of divisions on the milliammeter and post your readings. Next, 30 divisions on the voltmeter. Okay, and the milliammeter divisions, you can note it down. and post it in chat box. We move on to 35 divisions. And note the reading in the ammeter. Post it in the chat box. Your 40 divisions on the voltmeter. Note down the readings on the milliammeter. Post your readings in the chat box. So, voltmeter reading. Okay, voltmeter reading 45 divisions and milliammeter readings. Please take the readings and post in chat box. Fifty divisions in the voltmeter, 50 divisions in the voltmeter, and please take down the readings on the ammeter. Please take down the readings on the ammeter. Please take down the readings on the ammeter and post it in chat box. 55 divisions on voltmeter. Yes. And you can take down the reading from the milliammeter and post it in the chat box. We have reached the maximum scale, so we cannot increase the biasing voltage further. So we stop our forward bias readings here. Post your readings in the chat box. Now we move on to reverse bias and study the IV characteristics. We are going to vary the voltmeter and see how the current varies. So we have to put on the power supply, change this knob minimum, the forward bias we don't need it, and we are at reverse bias, so we are going to use this knob and vary the voltmeter and take the ammeter readings. Okay, let us study the least count of the instruments that we are using. The microammeter, it is of a range 0 to 100 microamperes, and here you have 0 to 20. From 0 to 20 there are 10 divisions, so the least count will be 20 divided by 10, that is 2 microampere is the least count of this ammeter. And for the voltmeter, the range is 0 to 30 volts, and between 0 and 5 volts it is divided, it has 10 divisions, so the least count will be 5 divided by 10, which is 0.5 volts. The least count of voltmeter, I repeat, is 0.5 volts. Please note down this. So we move on with the first trial in steps of 5 divisions as we did for forward bias. So we are going to vary the voltmeter till it's going to read 5 divisions. So this is 5 divisions on voltmeter, and please see the corresponding microammeter reading and post it in the chat box. Trial 2, 10 divisions on the voltmeter. Please note down the microammeter readings and post it in the chat box. Trial 3, 15 divisions on the voltmeter. Please note down the corresponding microammeter readings. Trial number 4, 20 divisions on the voltmeter. Note down the corresponding microammeter readings and post it in chat box. The voltmeter has been set at 25 divisions. This is trial number 5. Note down the corresponding microammeter readings and post in chat box. Trial number 6, 30 divisions on the voltmeter. It has been set at 30 divisions on the voltmeter. Take the corresponding microammeter readings and post it in chat box. Trial number 7, 35 divisions have been set on the voltmeter. Take down the corresponding readings in the microammeter. Post it in chat box. Trial number 8, 40 divisions on the voltmeter. Take down the corresponding readings on the microammeter. Post it in chat box. Trial number 9, 45 divisions on the voltmeter. Take down the corresponding microammeter readings. Post it in chat box. Trial number 10, 50 divisions on the voltmeter. Please note down the corresponding microammeter readings and post in chat box. Trial number 11, 55 divisions on voltmeter. 55 divisions on voltmeter. Please take the corresponding microammeter readings. Please take the corresponding microammeter readings and post in chat box. So the final trial of this experiment, trial number 12. There are fluctuations in the voltage. We have to wait till it settles down. So it has been set to 60 divisions, 10, 20, 30, 40, 50, 60 divisions, and the corresponding microammeter readings you can take and post in the chat box. Take the microammeter readings and post in chat box. Note the observation for forward bias. Range of voltmeter 0 to 1.5 volts. Least count of voltmeter 0.025 volts. Range of milliammeter 0 to 15 milliamperes, and least count of milliammeter 0.25 milliampere. And these are the readings. Please check your readings. Observation for reverse bias. The range of voltmeter used for reverse bias is 0 to 30 volts. You need a higher volt battery biasing source because of the depletion layer. It is reverse biased, and because of the increased depletion layer. Then least count of voltmeter is equal to 0.5 volts. Range of microammeter is 0 to 100 microampere. Note that the current is very small here, and least count of microammeter is 2 microampere. These are the observations. Please check your observations once more. With the recorded observation, you need to plot a graph. This region of the graph, region 1, is for forward bias, and the third one is for reverse bias. So forward bias, note down the scale. You could use your a scale of your own and plot the various points for different forward voltage and the corresponding ammeter readings. And similarly for reverse bias, take a suitable scale and plot the graph, and notice the diode starts conducting here, it is not conducting initially, it starts at 5 and it obtains a steady state of at around 15 into 0.025 volts, that is around 0.375 volts. This is the knee voltage. This is due to the depletion region of the diode, where you need some value of voltage for the diode to start conducting. And again, observe in the reverse bias, with the increase in the voltage, there is no major variation in the current. The current increase is very small when compared to this increase. This is because the current is due to minority charge carriers. So the number of minority charge carriers will be less, and therefore current is also less. Finally, the result, the IV characteristic curve of the PN junction in forward bias and reverse bias were drawn and analyzed. The value of cut-in or knee voltage for the given diode is 0.375 volts. Precautions. Find out manufacturer's specification for maximum permissible current through the given diode in forward bias. Take care not to exceed this limit, and for this particular diode it is 35 milliamperes. Find out manufacturer's specification for maximum reverse voltage to be applied to the diode. Take care that it does not exceed this limit, and for this particular diode it was 30 volts. It is important to take care that the potential difference across the diode is increased gradually in small steps. Keep your eyes on the ammeter and let the current not exceed the specified limit. Sources of errors. All connections should be neat, clean and tight. The PN junction should be properly biased. Voltmeter and microammeter or milliammeter of appropriate least count and ranges are to be chosen, and zero error, if any, in the voltmeter or milliammeter should be nil. Points to ponder. If we use different diodes made of germanium or silicon, what change do you observe in the IV characteristics? Does the threshold voltage or knee voltage or cut-in voltage of the diode depend on the material of the diode? How can you operate diode as a switch or as a rectifier? What is the difference between a diode and a resistor? If a resistor of high value greater than the resistor is connected in the circuit, greater than the resistance of the diode is connected in the circuit in series, then comment on the slope of linear region of IV characteristics. On behalf of Physics Department, Delhi Public School, Bangalore East, I would like to thank the management, principal for her constant guidance and support, and all physics teachers who have made the physics virtual lab a reality. Remember to note down the date and complete your records. Thank you, dear students.